This is the Tree of Life, Season 14, Chapter 8. In this episode, we will be talking about how the binary logarithm can be used to determine the minimum number of structure members associated with a given pair of dialectical impulses producing a particular bodily rhythm or cycle. To start off, in the last episode, we imagined that we were describing a 5-person structure comprised of persons A, situated above persons B, C, D, E. We imagined that person A affirms one impulse and negates a dialectical impulse for persons B, C, D, and E. That is to say, that there are 16 different conformations to this structure. We also observed that if the period for any one of those individuals, associated with affirmation of one impulse and negation of the dialectical one, is longer than the rest, then during the time associated with the difference between the first and the remainder, the number of configurations is halved. We can use this information to draw larger conclusions. Firstly, since we know that if one individual has a longer period associated with flipping of phase, it reduces the number of configurations by a factor of 2. Thus, if for person B, the period is longer than for C, D, or E, with affirmation of impulse 1 and negation of impulse 2, then the difference between that longer period and the period associated with C, D, or E results in a halving of the conformations during the difference. But imagine we are talking about a situation where B has a longer period than C, D, and E, but C has a longer period than D and E. In that case, there is a similar reduction in the configurations available during the time associated with the difference between C and D and E. In other words, this same effect which saw the number of configurations halved, because of the period of B being longer than C, D, and E, could produce through a stacking of the effect, a reduction in available conformations by a factor of 4 and so on and so forth. Thus, we see that the binary logarithm doesn't just reveal the order associated with sublimation by elongation of a phase. Nor does it merely reveal the orders of each cycle. It also reveals how many periods associated with dialectical impulses are stacked during the period of the longest cycle. It also shows us the minimum number of structure members to the structure associated with a particular bodily rhythm. For example, if we imagine that we are talking about the sleep cycle at binary logarithm of 16, then we see that this logarithm is associated with a stacking of 16 periods, associated with pairings of 16 dialectical impulses within a larger structure. Thus the total number of structure members is 16 plus 2, 1 for A, or the central individual, if they are all situate around the same individual, and 1 for some member X, who has the shortest period, that is, 2 configurations. Now, this does not mean that this 18-person structure is the only structure which could produce this binary logarithmic bodily rhythm. But it is merely the smallest structure which could produce the sleep cycle. Since we see that the larger structure could be broken into smaller substructures, i.e. a primary, secondary, tertiary, etc. structure, we see that larger structures could produce the same rhythm. That's the end of the podcast for today.